Okay, today we're going to take a closer look at the graphs of quadratic equations. So we've already worked on solving quadratic equations, and we've done a little bit of graphing, and now we're going to put these things together. So we already know that a quadratic function is any function of the form f of x equals ax squared plus bx plus c. And we already know how to find when this function equals 0. But now we're going to review some of the properties of graphs. So the first thing is the graph of any quadratic function is always a parabola, which means that it's got a U shape. And depending on what the coefficient a is, it's either going to be a U shape that's cupping up, or it's going to be a U shape that's cupping down. And so if a is greater than 0, it's cupping up, and if a is less than 0, it's cupping down. So a kind of tells you whether the function is happy or sad. If a is positive, then the function's happy, it's smiling. And if it's negative, then the graph is frowning. So that'd be like that. It's cupping down. Okay. The vertex is going to be a point I'll call h comma k. That's the vertex. And we can't see how to find h or k quite yet, but we'll see that in a second. And then finally, the graph, this U, is actually symmetric about some axis, and that's called the axis of symmetry. Okay, so these graphs are always symmetric. I mean, they're a U. They're symmetric about a line, and that line's going to be of the form x equals some number, and actually that number is going to be h, the x value of the vertex. So again, this is the axis of symmetry. Okay, so that's a quadratic function, and now there's a thing called the standard form of a quadratic function, and that is an equation of the form f of x equals a times x minus h squared plus k. Okay, and the reason why this is the standard form of the equation is it actually tells you exactly what the vertex is, so the axis of symmetry in this case. So we'll work on putting functions into standard form in a second. But this is nicer because you can actually graph the function very quickly. You just go to h comma k, and you look at a, and you say, oh, this is going to be a parabola cupping up or down, centered at the vertex h comma k.